Bismillahirrahmanirrahim. As you know, we are studying our chapter 8, that is automatic transmission, transaxle principles. So this is our 8th chapter which we are studying. Now the basic slide which we have, the powertrain flow of a conventional rear-wheel drive vehicle, engine, where the power developed, flywheel, clutch, and goes to the gearbox, then propeller shaft, differential box, distributed to right and left. Then we have covered the brake, suspension, steering, and now we are studying automatic transmission, the hybrid vehicles. So this was the basic diagram of automatic transmission. We have an engine, then we have a flex plate here, and then we have this torque converter, and then we have this hydraulic pump, then clutch packs, the compound planetary gears, the output shaft, and the extension housing. Here we have the oil and hydraulic valves. So this all portion is known as your automatic transmission. So we have covered this thing, the parts of the automatic transmission. I have changed the sequence. Now we have covered in our last lecture the torque converter. Now today's main topic is the planetary gear set. Then pump, multiple disc clutches, brake band, and forward running clutches. We have already talked about this torque converter. Torque converter, this is a quick recap of the last lecture. The torque converter is located between the engine and the transmission. The torque converter is located between the engine and the transmission transaxle and performs the following function. These are the three following functions: that transmits and multiplies engine torque, act as a clutch between the engine and the transmission oblique transaxle, allows slippage, which makes it possible for the transmissions to be engaged in gear when the vehicle and the wheels are stopped. So these are the three basic parts of a torque converter: impeller, turbine, and stator. We have discussed these things in detail. And then this is the cutaway model of a TRANSAXLE transmission. Then we have the pump, turbine, stator, front cover, lockup, clutch. And this was the simplest example of a two fan. One is powered and other is not powered, and it is when powered moves, it gives a flow of air and it tries to move the stationary in the direction of the flow. So this was the principle of the flow in the turbine and impeller and what the stator does. So these are the split rings which are used there. Then we talk about the torque converter flex plate, which is performing a little bit function of replacing the heavy flywheel in a manual transmission. Then a few words regarding the Then we are the flat screen that are cut. These are the flat screen, and this is the shaft, input shaft. Then we talk about the two types of flows which are present in the torque converter: rotary flow and the vortex flow. Initially, it was the vortex flow. Then it becomes a rotary flow when the speed is more. We have discussed this thing, and this is the torque multiplication phase. Torque multiplication occurs when the vortex flows takes a full cycle for impeller to turbine through the stator and back to the impeller. The torque converter multiplies torque in relation to the speed ratio. At lower speed ratio, the impeller engine is running much faster than the turbine transmission input shaft, so the vortex flow is high and the torque multiplication occurs. As the turbine speed increases and approaches impeller speeds, the rotary flow increases, which reduces both vortex flow and the torque multiplication. As the speed ratio approaches 90%, the torque multiplication becomes minimal and the torque converter functions like a fluid coupling. So this was the previous lecture which of regarding automatic transmission, the torque converter. Now we are few words regarding the one subtopic of the torque converter, that is the lockup torque converter. Now, what is lockup torque converter? The purpose and function. Even the most efficient torque converter slips 8 to 10% during operation. So there is a wastage rate in a torque converter, that is the torque converter slip. That is 8 to 10, 12% during operation because of the fluid hydraulic properties. The fluid that transmits torques exhibits a type of slippage known as fluid shear. Fluid shear creates friction heat, but this heat performs no work when the different layers of fluid slide past each other. So we have a slippage or slip, torque converter slip, that is 8 to 12% during the operation, and this is due to the fluid shear, and fluid shear creates friction heat, but it takes no parts in the performing a work on the torque converter. So the eliminating torque converter slippage can improve fuel economy approximately 4 to 5% during freeway cruising. So if we can minimize or reduce this slip 8 to 10, which is 8 to 12%, so it can improve the fuel economy from 4 to 5% during freeway cruising. An additional benefit to reducing slippage is a reduction of transmission operating temperature. So the fluid which we are using, the heat properties which are disturbing or damaging the fluid properties, we can save that, and the transmission operating temperature is reduced, which increases transmission life expectancy. So the lockup torque converter reduces slippage by using a torque converter clutch. So in order to reduce this slippage, we use a lockup torque converter, lockup torque converter, which is used to reduce the slippage of the torque converter clutch to lock the impeller to the cover, that is your shell. Similar to a clutch for a manual transmission, our torque converter clutch uses a friction disc operated by a hydraulic pistons to mechanically couple the turbine to the converter cover or shell. So basically, these are the friction discs which are operated by a hydraulic piston or hydraulic mechanism in order to mechanically couple the turbine to the converter or cover of the shell. Engaging the clutch creates mechanical connection between the engine and the transmission, resulting in a direct 1:1 drive ratio without slippage. So when we engage the torque converter clutch, it basically engages the mechanical connection between the engine and the transmissions, resulting in a direct drive ratio, and so will be a no slippage. So this is the figure in which we are using this torque converter clutch friction discs. So these are the torque converter friction discs. Torque converter clutch friction material is determined by a vehicle manufacturer to provide the needed coefficient of the friction needed. So it is designed very carefully by the OEM or the vehicle manufacturer so that it should have enough friction to engage. For example, many older units uses a paper type friction material because they are fully applied or released, whereas most new units are using the synthetic materials such as Kevlar or carbon fiber because the torque converter clutch is pulsed on and off, therefore requiring a most robust material for long service. So we have this carbon fiber layer, the Kevlar layer, and the paper layer. They are used separately. Now in this figure, we have an engine on in this side. This is your flex plate, and this is your turbine, and this is your impeller and stator, and this is the input shaft to the transmission. And this is the modulated applying pressure here, and this is the clutch disc. A cross-sectional view of a pulse width modulated pulse torque converter clutch. A powertrain controls module pulses the control solenoid, which then controls the fluid flow to apply the torque converter clutch. So in this setup, we have a pulse width modulation, which is controlled by powertrain control module of an engine or transmission that basically applies the modulated pressure and which helps to engage the solenoid switch for the disc clutch, this hydraulic clutch here, torque converter clutch. Now, the torque converter clutch operates under the following condition. These are the conditions under which this your torque converter clutch operates. Lockup may also be limited to specific vehicles or operating conditions, speeds over 25 to 30 miles per hour. So it is lockup clutch may also be limited to specific vehicles, speeds or operating conditions, speeds over 25 to 30 miles per hour. Once lockup occurs, the clutch may disengage automatically during certain operating conditions, such as part or full throttle downshift. So, once a lockup occurs, the clutch may disengage automatically during certain operating conditions, such as part, throttle, or full throttle downshift. Most computer systems can lock and unlock or modulate a converter clutch hundreds of times per minute. So, in 1 minute, it can engage and disengage hundreds of times. Partial lockup converters allows a regulated amount of slippage at the clutch. This allows the converter to lock up smoothly, improving fuel economy and performance without the drawback of shock to the driveline. So this is very important. The engaging and disengaging should have to be smoothly. So when it is lockup is converter is lock up smoothly, it improves the fuel economy and performance without the drawback of shock to the driveline. Using the wrong type of automatic transmission fluid can alter the friction properties of the lockup clutch. So the transmission fluid which the OEM has specified, you must always use that transmission fluid. Don't try to change that transmission fluid with the advice of the local mechanic, because OEM has specifically designed or suggested that specific transmission fluid which are to be used, because it will alter the frictional properties of the lockup clutch. So most lockup converters automatically disengage the torque converter clutch each time the brake pedal is depressed by the driver. So everything depends upon your foot. When you are engaging or disengaging, the most lockup converter automatically disengages the torque converter clutch each time the brake pedal is depressed by the driver, or if the accelerator pedal is released for more than a couple of seconds, which is necessary for vehicle deacceleration without stalling the engine. This was talking about this figure. Now you must have seen that automatic transmission vehicle, on gear lever or the shifting lever, you have this P, then R, then N, D, 2, and L. P is for parking, R is for reverse, N is for neutral, D is for drive, and then you have 2 and L. These are the specific conditions where you can engage these two modes. And you have on internet or any TikTok or social media, you must have heard the conversation that it drives in N and not drive in night and drive in day. The joke you must have heard it. So the gear selection is often called as the Prendle, pronounced Prendle, P regardless of the actual letter or number used. Now, coming towards the main topic of today's lecture, that is the planetary gear system. We have in two gear system. In manual gear system, the simple gear is meshed with other gear in simple transmission, or the manual gear, we have a synchro mesh gear mechanism, synchronized mesh with the other gear to the power flow. But this planetary gear system is a little bit different from that manual meshing. So we have different set of gears here. First, the center one, this is known as the sun gear. Then this blue one, these are called planetary gears or pinion gears. They may be 3 in number, they may be 4 in numbers. Okay. Then we have this outer gear or the ring gear. In general, we have internal teeth here. But in some cases, we might have external teeth also. So this is the planetary gear set, combination of three types of gear: the sun gear, the planetary gear, and the ring gear or the outer gear. So we'll study detail today in this lecture. The purpose of this planetary gear: in a manual transmission, different gear ratios are obtained by sliding the gear into mesh. However, torque flow must be momentarily interrupted and accomplished by using a clutch before the gears are shifted. So when we apply a clutch and they change the gear, the torque flow is momentarily disturbed in the manual transmission. But with an automatic transmission, there is no driver operated clutch, so gear shifts are not made by sliding gear into mesh. So this is a difference between the manual transmission and the automatic transmission, that in automatic transmission, there is no driver operated clutch, so gear shifts are not made by sliding gears into mesh. Most automatic transmissions use a planetary gear set systems that does not require manual gear shifting or an interruption of torque flow to the changing gear ratio. So in most of the automatic transmission, we use planetary gear set system. There are other mechanisms also in which automatic transmission, but the simplest one is the planetary gear set system that does not require manual gear shift system or an interruption of a torque flow to the change gear ratio. There are other systems we will touch upon in our next lecture. The planetary gear set torque flow, how the torque is flow in the planetary gear set. In planetary gear sets, the following is done to achieve the various gear ratio and reverse condition. So as we know, we have three members: sun, the pinion, and the ring gear. So one of the member is being driven. So either it may be sun or pinion or ring. We give input to that. One of the member is being held. So the other member out of the two should be held. It either, if we are giving input to the sun, either way we can have this reactionary member, maybe the pinions or the rings. And one of the member is the output. If we are holding the pinions here, then the output will be achieved from the ring gear here if we are giving the input to the sun. Now, the simplest, a typical planetary gear set showing the terms that are used to describe each member. The blue one is the sun gear, the green ones are the planet pinions or carrier, planet carriers we call it, and the brown one is known as the ring gear, or which we have internal gears or annulus gears. So this is the typical planetary gear system which we used. Now here, this is a little bit different. A typical planetary gear set showing a planet carrier. Now we have these three planet pinions here, or pinion gear or planet gears. When we join them, all three pinion gears are joined with the help of this arrangement. Then we call this arrangement as planet carrier. And these gears are known as planet pinions or pinion gears. And this arrangement, which we are joining the pinions, are planet carrier. Then we have the sun and the ring gear. So the typical planetary gear sets showing the planet carrier, which supports all the pinion gears, also called planet pinion gear. So we call it a planet carrier or planet pinion gear if we have this sort of arrangement with the pinion gears. Now we are giving input here. A maximum reduction can be achieved by using the sun gear as the input, holding the ring gear, and using the planet carrier as the output. So maximum reduction can be achieved here. We are giving input to the sun. We are holding this ring gear and taking the output from this planet carrier. So pinions walking inside the ring gear, and we are achieving this output from the planet carrier or this pinion carrier. So in this case, the maximum reduction can be achieved by using the sun gear as the input, holding the ring gear, and using the planet carrier as the output. So this was the one condition in which we have a maximum reduction. Now let's see another figure in which here we are giving input to the sun, but here we are holding the sun, and we are giving the input to the ring gear and taking the output from the pinion. So minimum reduction can be achieved by using the ring gear as input, holding the sun gear, and using the planet carrier as the output. So in this case, the input is going to the sun and output is coming from the pinion carrier, and ring is stationary. But here, sun is stationary, input is coming from the ring gear, and the output is from the planet carrier. So the minimum reduction can be achieved in this case. Now let's see another case. Here we are giving the input to the sun, we are holding the planet carrier, and we are getting the output from the ring gear. So reverse can be achieved by using the sun gear as the input, holding the planet carrier, and using the ring gear as the output. So in this type of arrangement, we get the reverse movement. When we are giving input to the sun, holding the pinion or planet carrier, and taking the output from the ring gear, then we have a reverse flow. Torque flow through a planetary gear. Torque flows through a planetary gear set in several steps to get from the drive action of the first member to the driven action of the last member. The terms drive and driven simply describe how any two gears works together. Input and output are drive or driven. When three or more gears are involved, the second gear is a driven gear in the relation to the first gear, but it becomes a drive gear in relation to the third gear. For this reason, the drive member of a planetary gear set is known as the input member, the held member is the reaction member, and the driven member is the output member, as already explained in the initial slide. So these are the basically 6 situations where we have different types of arrangement. Sun gear, planet gear, ring gear, speed, torque, direction. So if we are giving input to the sun and we are taking output from the planet carrier and we are holding the ring gear. So in both the cases, we are holding the ring gear. So input it to the sun, planet carrier, and speed maximum reduction will be there, torque will be increased, direction both will be in the same direction. So we will go moving forward. Now, if we are getting output from the sun and giving input to the planet carrier and the ring gear is held, so there will be a maximum increase in the speed, reduction in the torque, same direction will be the same. Now, let's see another case where we are holding the sun in these two conditions. We are holding the sun gear. Output is we are getting from the planet carrier. Input we are giving from the ring gear. There will be minimum reduction, increased torque. The direction will be same as input. Now, again, the sun gear is held, giving the input to the planet carrier. In first case and the previous case, it was the output. Now the input to the planet carrier, ring gear, we are getting the output. So minimum increase, so reduction in torque, same as input. Input drive. Now we are now holding the planet carrier here and giving the input to the sun and taking the output from the ring gear. So speed will be reduced, reduction there, torque will be increased, and direction will be reverse of the input. So we are going reverse. Now we are taking output from the sun gear, planet is held, input to the ring gear, the speed is increased, torque is reduced, reverse of the input. These are the 6 cases of a planetary gear set, but there are 2 other cases also. If any of the 2 members are locked, then the resulting output is 1:1 in the same direction as the input direct drive. So if we are giving input to the sun and these two members are locked. Planet carrier or ring carrier, both are locked. So there's 1:1 drive. So it is a direct drive. If no member is locked, then there is no output and we are in the neutral gear. So no one is held, everyone is freely rotating. So there will be no output and we will having a neutral gear. So these are the 8 conditions in which different arrangement, with the help of different arrangement in the planetary gear set, we receive different speeds and torque and directions. So this is basically we are giving power input to the ring gear, then yellow is the power output to the planet carrier, and blue is the sun is the stationary. So these are the few conditions and some other condition. Same chart which I have shown you previously. Here it is when any two members are held together, speed and direction are the same as input. So the direct 1:1 drives occur. When no member is held or locked together, output cannot occur. The result is in neutral condition. So I will explain with the help of drawing in our lecture how we can have this speed and direction in the same direction or in the reverse direction, and the what will be the speed or torque. The same chapter, same chart, and this is the calculation which we will talk in the next chapter, inshallah. Thank you very much.